Do you want to ask anyway, and I'll just leave it alone?
On one of the questions, the same question, I get 5 out of 5, and he gets 4 out of 4. Oh, yeah. Yeah, different. And then just one. This is a. Oh, you know what? Yours probably got on first, and I changed mine. So yeah, you know, yeah.
I changed my mind on how many marks I was going to assign to things. Okay. Where did it go? There we are. Oh, we're recording. Okay, good. So, question. Do you guys have any questions from any of the stuff you did over the weekend? Yes. Oh, from the quiz? Oh, from the worksheet. Yes. Like the 3.2a? Okay, yes, 4 and 12 from 3.2a. Oh, that's my answers. There we go. Okay, so we have number 4. This is 3.2a. Number 4. And we have 1 gram of copper sulfate, pentahydrate, dissolved to make 50 milliliters of solution. And we want to know the ion concentrations, yes? Okay, so what we need to do first of all is we need to find the molar mass of this thing, which is going to be the mass of copper, sulfur, 4 oxygen, and 5 water. So the reason this one's a little complicated is because it is a hydrate. So let's just add those up. Copper has a mass of 63.5. Sulfur is 32.1. Oxygen is 16.0, which we are going to multiply by 4. And water, I happen to know, is 18 because it's 16 and 2. So that's 18 times 5. So I'm going to take all of those and add them up. 63.5 plus 32.1 plus 16 times 4 plus 18 times 5 is 249.6. Now we have 1 gram, so the moles of Cu SO4 5H2O is equal to 1 gram times 1 mole per 249.6 grams is 4.006 times 10 to the negative 3 moles. Now we want our concentration of copper sulfate. The water has nothing to do with it. So if you imagine that we have our crystal, right, and inside the crystal we have some water molecules. Okay. As the crystal dissolves, each one of these will, come off. Any water that was in there will just be released and will just go join the rest of the water and be part of the solvent. Yes? So we really don't have to worry about that water at all, other than the fact when we're taking our grams and turning it into moles, we need to have that water as part of the molar mass. Okay? Because there's one of these for every one of those will be the same. So that's going to be 4.006 times 10 to the minus 3 moles per 50 milliliters, 0.050 liters, and we get 0.0801. Now this compound contains 1 copper, yes, and it contains 1 sulfate. So therefore the concentration of copper and the concentration of sulfate will be the same as each other, and they will be the same as the concentration of CuSO4, which is going to be 0.080 molar. Did that answer your question? Cool. Excellent. We're also going to look at number 12. We have, okay, I'm just going to rewrite this over here. We have 75 milliliters of 1 molar lithium nitrate. And we have 115 milliliters of 2.50 molar iron chloride. And we want to figure out the concentration of each solute and then the concentration of each ion. So if we mix these two, we are going to get a total volume which is equal to 75 plus 115, right? Because we're mixing those two together. So 75 plus 115 is 190. So that's our total volume. And now we need to do a dilution calculation for the lithium nitrate and for the iron 3 chloride. Do you have a preferred method that you like to use? You don't mind either? Can I show you a new one today? Okay, I'm going to show you guys a new dilution calculation. It's actually just M1V1 rearranged, but I like to call it the noon method. Your new concentration is equal to your old concentration times your old volume over the new volume. So this is just a rearrangement of M1V1, but for myself, I find it more intuitive. Like I find with M1V1, I'm always wondering what I'm putting in the right place. For this one, I never kind of wonder. I'm always like, oh, the small number goes on the top and the big number goes on the bottom. So I end up with like a fraction of my concentration because I have made it into a bigger volume. Yes? So let us use that to find our new concentration of LiNO3, and we want to have that diluted. So I'm going to write a little dill there for diluted. My old concentration is 1 molar. My old volume is 75 milliliters. My new volume is 75 plus 115, that was my 190 milliliters. And we get 75 divided by 190 is 0.3947 molar. Now I could take that to correct sig figs and make that 0.395. In terms of ion concentrations, how many lithiums are in here, in that compound? Just one. And there is also one nitrate. So the concentration of lithium and the concentration of nitrate will simply be the same as the concentration of lithium nitrate, which will be 0.395. So far, so good? Okay. Now we're going to do iron 3 chloride. So we have concentration of FeCl3, and we are diluting it. We started with 2.50 molar. And our initial volume was 115 milliliters. And now we have a larger volume of 190 milliliters. 2.5 times 115 divided by 190 is 1.51. And you'll notice your milliliters cancel out, so your unit is molar. Concentration of iron. How many irons in here? Just the one. So that's going to just be the same as the concentration of iron chloride. So that's going to be 1.51 molar. Chloride, on the other hand, how many chlorides do we get? 3 chlorides. So what am I going to have to do with that concentration to find chloride? I'm going to have to multiply it by 3. .53 molar. Did that make sense? Cool. We are going to be using these dilution skills today, so I'm glad that you asked about that, okay, because we'll be totally using that in our Q calculations. Are there any other questions from 3.2a or 3.2b? I know that the answer key for 3.2b, number 4, was incorrect. So the corrected key is here. We did this in block 1. So if you're looking for that, I will post that in today's notes, okay? This is 3.2b, number 4. Answer key was wrong. Unless you think it was right. But nobody in block 2 thought it was right. So what did you guys think? Wasn't good? Okay. This should be better. All right. Any other questions on anything? How are we feeling about Q, having watched the video? Huh? Sort of semi there? Semi there. Let's do a couple of examples using Q. So this is 3.2c. And I'm going to let you know right now that I did not leave enough room for this question. If I were you, I would just get a blank piece of paper to do this on, because I did not leave enough room here. In fact, I'm going to copy this down over here. Will a precipitate form if, because I tried to do it this morning and it was just a god-awful mess. I really need a whole page for each question for this one. If 100 milliliters 1 times 10 to the negative 4 molar AgNO3. What page is this on? Let's see. Sorry? 65. We are on page 65. Thank you so much. Is mixed with 100 milliliters of 2.0 times 10 to the negative 4 molar calcium iodate. So the first thing that we're going to notice about this question is that it says, will a precipitate form? Now, you guys are used to seeing questions, will a precipitate form? If equal volumes of 0.2 molar X and 0.2 molar Y are mixed. If you saw that kind of question with the 0.2 molar and the 0.2 molar, where would you look to solve that question? That would just be your solubility table, yes? However, that solubility table works because these ion concentrations they're above 0.1, so they are large concentrations, yes? Do we have such large concentrations here? No, these are smaller concentrations. Okay, so we cannot just use the solubility table because the solubility table doesn't work for smaller concentrations. What tool in our toolbox do we need to use if we have smaller concentrations to predict if a precipitate will form? We're going to use our Q value, okay? Because it will tell you if your ion concentrations are too high, in which case a precipitate will form, or are they too low, in which case a precipitate will not form. Before we do anything though, we need to look and say, if I'm going to have a Q, then I need to have some sort of low solubility compound, yes? So before I start anything, I need to predict who will the precipitate be, because I've got two compounds, yes? Anytime you have two compounds in a question that needs a Ksp or a Q, you need to say who is the precipitate. So you have to identify the precipitate first. So if we look at our two compounds, we will be combining our outside ions and we will be combining our inside ions. are either of those two soluble and therefore not the precipitates? Calcium nitrate is soluble because we know that nitrate is soluble with everything. So even though iodate is not on our data booklet of common ions, like you can look around here all you want, you're not going to find an iodate, yes? However, if the question is asking us, does a precipitate form, and we're given somewhat low ion concentrations, I don't know why this ended up so weird, there we go. We can assume that our precipitate is going to be the silver iodate, okay? So step number one is identify the precipitate, which is AgIO3. Second thing we can do, you can actually go a couple of different routes here. Do you guys like finding your ion concentrations first, or do you like writing your Ksp or your Q first? Or do you not care? Don't care? I kind of like finding my ion concentrations first. So I need to then, because it's silver iodate, I need to find the concentration of silver and the concentration of iodate. So next we're going to find the ion concentrations. So for silver, where is the silver coming from? Coming from silver nitrate. If we go back to our question, that's where it comes from. So it comes from AgNO3. But we can't form a precipitate until we've mixed those two solutions together. And when we mix them together, what does one volume do to the other volume? Or what does one solution do to the other solution? They dilute one another, okay? So we are going to have to do a dilution calculation. So our concentration of silver, oh look, this is a 1-to-1 ratio, yes? So I can say then that my concentration of silver is equal to the concentration of silver nitrate. But because I am mixing those two solutions together, I'm going to have to calculate what this is diluted. So when you're doing your dilution calculation, you may do it any way you want. If you want to use the mole method, that's great. If you want to use M1V1 equals M2V2, that's great. I'm going to stick with noon because I like it, but feel free to use whatever method you like. So my old concentration of silver nitrate is up here. It is 1.0 times 10 to the minus 4. Molar. That is our undiluted AgNO3. Normally you wouldn't write that, I'm just annotating for you. Times, and what do we put on the top of this little times thing? Old volume, which is 100 milliliters. And our new volume, we have mixed two solutions, each of which is, oh, that didn't work nicely. That was supposed to be a highlighter. Try that again. We have mixed two solutions, each of which is 100 milliliters. So our new volume is going to be 200 milliliters. We follow that? 100 and 100 gives us 200. So our new volume is 200.0 milliliters. Another reason that I kind of like this is that the whole fractional approach makes sense in my head. I've doubled the volume here, yes? What happens to concentration if I double the volume? It goes in half. Oh, look what fraction I have here. I have a half, yes? So it actually shows you like what fraction of my original concentration is my diluted concentration going to be. If you didn't follow that, you can just ignore and pretend I said nothing, okay? But we do that and we get, I think it's 5 times 10 to the minus 5, but let's just check because I don't trust myself. Yep, 5 times 10 to the minus 5 molar Ag plus. And I'm going to put a red box around that so that I can find it easily later. We have found our silver. Our other thing that we're going to need to find is our iodate concentration. So our concentration of iodate. Where does iodate come from? Go back to your question and tell your partner, where does the iodate come from? Yeah, it comes from calcium iodate. So I'm not going to be able to do this thing where I just say the concentration of iodate is equal to the concentration of calcium iodate because I have this little 2 here, yes? So you can show it however you like to. I kind of just like to find my diluted concentration of calcium iodate first and then find the concentration of iodate, but you can do it whichever way you like. Concentration of calcium iodate diluted equals our old concentration, 2 times 10 to the minus 4, yeah. 2 times 10 to the minus 4 molar, and again we had an original volume of 100 milliliters, and we mixed it up with the other one and got a final volume of 200 milliliters. Milliliters cancel. And we get 1.0 times 10 to the minus 4 molar. And that is calcium iodate, CaIO3 2. What's the concentration of iodate? Tell your partner. Will it be the same as that? Will it be 2 times that? Or will it be half of that? What do you think? Is iodate the same as calcium iodate? Is it twice as much, or is it half as much? How much is it? Twice as much, because you have 2 iodates for every 1 calcium iodate. So you can say, okay, that's going to be 2 times the concentration of calcium iodate, which is equal to 2 times 1.0 times 10 to the minus 4, which is 2.0 times 10 to the minus 4 molar iodate, IO3 minus. And again, I'm going to put a box around that so I can find it easily later. So these Q questions, they involve a lot of different steps, but each step you know how to do. Do you know how to predict who the precipitate is? Yes. Do you know how to do a dilution calculation? Hopefully, yes. So we've come that far. Do you know how to do a Q? Yes. In order to write a Q expression, so the first thing we did, we identified the precipitate. Second thing we did, found our ion concentrations. The third thing we're going to do is we're going to use a Q, but in order to write a Q, before we can write a Q, we need to write the solubility equilibrium equation, also known as the SE. Nobody calls it that but me, but I get tired of writing it, so that's what I call it. So this is for silver iodate. Where does the solid go? On the left or on the right? On the left, AgIO3, solid in equilibrium with Ag plus IO3 minus, aqueous and aqueous. And having written that, we can now write our Ksp or our Q, depending on what's appropriate to the question. In this case, we want to write a Q. So Q is equal to the concentration of silver times the concentration of iodate. And then we just plug things in at that point. Okay, so we say, all right, I'm going to go back and find my numbers. There they are. So we have silver right there is 5.0 times 10 to the minus 5. That's in our first red box. In our second red box, we have iodate 2.0 times 10 to the minus 4. And we get 1 times 10 to the minus 8. And you'll notice I'm playing fast and loose with my sig figs here, but that's because I got an actual value that was 1, and Q is just used as a comparison, so its sig figs don't really matter too much. Does that make sense? So we found our Q. What do we do with the Q value? We compare it to Ksp. So Q is 1 times 10 to the negative 8. And Ksp for silver iodate, what do? I don't know what that is. And doesn't tell me in the question. What do I do? Figure it out. Well, I'm not given enough data to figure it out in this question, so what could I do? I could hope that there is something in my Data booklet. Let's go check it out and see if there is a Ksp for silver iodate. Oh my goodness. Looky there. And if you were unsure if your precipitate was silver iodate, you can always check this table and say, hey, is it on there? Oh yeah, it is. That probably is my precipitate. So it's 3.2 times 10 to the minus 8. That's nice. Keeps taking me back to the beginning. That's irritating. That's okay. Come on. Oh, misbehaving. Sorry. Let's take another minute here. Oh, there we go. Okay. So that was 3.2 times 10 to the minus 8. So is Q bigger than Ksp or less than Ksp? It is smaller than Ksp. And remember, this Q and Ksp are both ion products. They are both concentration of A times concentration of B. So my ion concentrations, are they too small or are they too big? Too small. So will we get a precipitate forming? No, because we don't have enough ion concentration. We don't have a high enough ion concentration. And I know the question didn't ask this, but this is another thing you could be asked in a question like this. Is this a saturated or an unsaturated solution? Is it saturated or is it unsaturated? Yes, it is unsaturated. We do not have enough ions to fill it up, so there will be no precipitate. Is good? Would we like one more example before trying some problems, or do you want to just give it a go? Give it a go? Okay. Anyone else want any other examples, or are we going to give it a go? Okay, let's give it a go. If you decide later you want another example, I've got another one, so you could ask about that, but yeah, just give a few of them a go. Okay, so that is on page, whatever the heck page that's on, I don't know. Try a few of the exercises, wherever they are. There we go. Did that pause the recording? Paused. Okay, there we go. No, that's recording. Who said they had questions? Yes? Okay. Yep. Shall we come back to it? Okay, let's come back to it. Did anyone have any questions from 3.2b? Going from solubility to Ksp. I'll let you know right now that number 4, the answer key was wrong. Okay, so for 3.2b, number 4, the answer key was wrong, and I've got the answer here, and I will post it up for you guys today. Okay, so 3.2b, number 4, the answer key was wrong. And that is the corrected answer. I don't think it's to correct, oh, maybe it is to correct sig figs. Okay. Anything else from 3.2b? Okay. In that case, we are going to go on to 3.2c. Did you guys watch the video over the weekend? No? Good. Okay, you should, because it's like, it's helpful. All right, we are on page 65. And I'm gonna let you know right now that I judged this very poorly. I should have left a whole page for this question. So I'm going to recommend that you use a blank sheet of paper for this question. So if you wanted to, anyone else like paper? Okay, so what I would do if I were you is I would, have the question up at the top, but then I would put my piece of paper underneath that question so that I can then write underneath it. Does that make sense? Because I really did not, I totally misjudged how much space this would take. So next time I do it, I will do it differently. So I'm going to rewrite this question over to the side here. So will a precipitate form if 100 milliliters of, I think it's 1.0 times 10 to the negative 4 molar silver nitrate is mixed with what was the other one? 2.0 times 10 to the negative 4, 100 milliliters of 2.0 times 10 to the negative 4 molar calcium iodate. Yes, calcium iodate. IO3 2. Now, up until this point, when you have been doing questions that involve will a precipitate form, they have looked like this. Will a precipitate form if equal volumes of 0.2 molar X and 0.2 molar Y are mixed. If you have a question like that, where could you look to find the answer? If you're given 0.2 molar of one thing and 0.2 molar of the other thing and you're asked, will a precipitate form, where could you look? You could look on your data booklet. This would be page 4, and it's pretty straightforward. Okay, so these ones you would just look on page 4 of the data booklet. But that only works because your concentrations are very high. Yes, these are high concentrations. Yeah. Well, not this part. We're going to do the Q. Yeah, yeah. Okay, so those are high concentrations. When you mix them, they'll be 0.1 molar. It's going to be, you know, pretty easy. Look at the data booklet. Are our concentrations high? No, they are not. So we cannot simply use page 4. Okay, these are low concentrations. Can't just use page 4. So, what tool do we use if it says will a precipitate form and we have these low concentrations? What do we need to use? We're going to use Q. Okay? Because we'll be able to look at it and say, either my ion concentrations are too high, in which case I will get a precipitate, or my ion concentrations are too low, in which case I will not get a precipitate. Okay? So the first thing we need to do, numero uno, is we need to decide who is the precipitate. So you need to identify the precipitate. And in order to do that, you need to look at your original 2 salts, because we have here not just one compound, but we have 2 compounds. Yes? So we're not looking at silver nitrate and we're not looking at calcium iodate, not really. What would the precipitate be if we mixed those 2? Well, if you get stuck on that, you can say, okay, I know I have Ag, NO3, and I have Ca, IO3. And just like any other double replacement reaction, you can look at what happens when you combine your outside ions and what happens when you combine your inside ions. Is there one of those 2 products that would be soluble? And so we don't have to worry about it. CaNO3, that is soluble. So that is not our precipitate. If we have a question that says, will a precipitate form? We can assume that one of the 2 products must be a precipitate, especially because iodate, you can go and look at your data booklet on page 4 until the cows come home, and you will not see iodate on there anywhere. There's nitrate, acetate. Anyone seeing iodate? No iodate. No iodate. You can always do a quick check on page 5 though and see, hey, do I see a silver iodate? I do. Yes, so that tells me that it is a low solubility compound. If it has a Ksp, it is a low solubility compound, even though it is not on page 4. Page 4 is just common ones. So that means that this is our precipitate. Precipitate is silver iodate, Ag. What is the charge of the iodate ion? It has to be IO3 minus, because there are 2 of them, and calcium, of course, is 2 plus, and so we have to have 2 IO3 minuses. So if we have IO3 minus and we have silver, which is plus, then that's simply going to be AgIO3 solid. So number one, identify the precipitate. Number two, you can choose which direction you go here. You can either find your ion concentrations first and then do your solubility equilibrium and your Ksp, or you can do solubility equilibrium and Ksp and then find your ion concentrations. I'm going to start with ion concentrations because they're a little bit complicated and I'd like to make sure we work through that, okay? So find the ion concentrations. Remember, we were mixing two compounds. We had to identify the precipitate, but we also need to take into account that we have 100 milliliters of solution A and 100 milliliters of solution B. What do those two solutions do to each other? They do react, but even more than that, because we're looking at finding our ion concentrations, we will get a precipitate, but before we know if we get a precipitate, we have to take into account the fact that the two solutions dilute each other when we mix them. We go from having a volume of 100 milliliters to having a volume of how much? 200 milliliters, right? Because we mixed 100 and 100. So when we are finding our ion concentrations, we will have to do a dilution calculation. So I would like to show you a new way of doing a dilution calculation. Feel free to keep using M1V1 equals M2V2, or just using moles, okay? This is actually, honestly, it is just M1V1 rearranged and given different names. This is the Noon method. Of dilution calculation. It's actually my favorite. I like it the best because it kind of makes sense to me, but you don't need to use it if you don't like it. And how it works is we have our new concentration is equal to our old concentration times our old volume over our new volume. So like I said, it's really just M1V1, M2V2 rearranged. Now, because our precipitate is silver iodate, which ions will I be finding the concentrations of? I want to find concentration of what and the concentration of what else? Remember, my precipitate is silver iodate. Which ions do I care about? Silver and iodate. Okay, so let's start by finding our concentration of silver. where does our silver come from? Yeah, if we go back up here, we can see that silver comes from silver nitrate. Yes? So let's go about finding then our concentration of silver nitrate, because that will lead us to our concentration of silver. But we want to find the concentration of silver nitrate after it is diluted, because once the two are mixed together, that's when we're going to say what happens at these new concentrations. Yes? So we are going to start with our old concentration for silver. Let's go back and look and see what that was. 1.0 times 10 to the minus 4. That's our old concentration. How much of that did we have? We had 100 milliliters. And then we mixed it with our other solution, and what's our final volume that we ended up with? 200 milliliters. And your milliliters cancel with the milliliters, and the unit you are left with is molar, which is what we want. And I believe our answer here is 5.0 times 10 to the minus 5. One of the reasons I like this method is that it makes it really easy for me to see things like, I went from 100 mils to 200 mils, so I doubled my volume, yes? What fraction do I have here? I have a half, so my concentration was halved, yes? So it's nice for showing that in a sort of an intuitive way, okay? All right, so there's my silver. I'm going to put a box around that, or actually that's my silver nitrate. What can you say about the concentration of silver compared to silver nitrate? They're the same because there is only one Ag plus in silver nitrate, yes? So I can say that my concentration of silver is the same as my concentration of silver nitrate, because there is one silver in silver nitrate. Yes? Are we good? Norman, how do you feel about that? Yeah? Okay, cool. And I'm gonna put a silver here, and I'm gonna put a box around that so I can find it easily later. That was my silver. The other ion we want to deal with is iodate. That is correct. Where does the iodate come from? Comes from calcium iodate. It's going to be doubled, yes. Okay, so we're gonna keep this little 2 in mind here as we travel through this question. But before we do that, I'm just going to find out what is my concentration of calcium iodate diluted. So concentration of CaIO3 2 diluted is equal to, and I think its original concentration was 2.0 times 10 to the negative 4 molar. It also had an original volume of 100 milliliters. And when we mixed the two, we got 200 milliliters. And that gives us 1.0 times 10 to the negative 4 molar. Can I just stick, don't write this down yet, can I just put this here and say iodate? Is that okay? that all right? Or is that not all right? I cannot do that because the ratio of calcium iodate to iodate, there are 2 IO3 minus in calcium iodate. Yes? So what am I going to have to do with the 1.0 times 10 to the negative 4? I'm going to have to double it. Yes. Okay? So concentration of iodate then is going to be twice the concentration of Ca IO32, which is 1.0 times 10 to the minus 4 times 2, which is 2.0 times 10 to the minus 4, and that is iodate IO3 minus. Excellent. So number 1, decide who the precipitate is. Number 2, find your ion concentrations. Probably have to do a dilution calculation like we just did here. The third thing we're going to do then is something that you do in every single KSP or Q kind of question. What are those 2 things we do in all Q KSP type questions? We write the solubility equilibrium equation. And we are dealing with silver iodate. Where does the solid go in our solubility equilibrium equation? Everybody, where does my solid go in a solubility equilibrium equation? It goes on the left. Excellent. AgIO3, solid. And then that's going to be in equilibrium with Ag plus IO3 minus, and both of those are aqueous. Once we have a solubility equilibrium equation, what can we write? We can write the Ksp expression. And in this case, we are going to write a trial Ksp. Yes, because we're trying to decide if a precipitate will form, or you could call it Q, whichever you prefer. Okay? So that's going to be equal to the concentration of silver times the concentration of iodate and we have to go back so that we can see our concentration. Oh, jumping all over on me. What's it doing? There we go. That's better. Our concentration of silver is 5.0 times 10 to the minus 5. And our concentration of iodate we found was 2.0 times 10 to the minus 4. So we get 5E5 times 2E4 equals 1 times 10 to the negative 8. I suppose I should write 1.0 times 10 to the negative 8, but I know I'm just doing a comparison and I don't really care about sig figs, but I'll put it in anyway. Once you have a K trial or a Q, what do you do with that? Yeah, we compare Q to KSP, so we're going to have Q, which is 1.0 times 10 to the minus 8, Uh-oh, I don't know a KSP. Wasn't given to me in the question. What do I do? It's in the data booklet, yes. And if it's not in the data booklet and it's not in the question, you can feel free to put up your hand and say, hey, Ms. Spence, we're missing a KSP here, okay? Because it should be in one of those two places. And it is, yeah, 3.2 times 10 to the minus 8. Excellent. 3.2 times 10 to the minus 8. So Q, is it bigger or smaller than KSP? Smaller. So does that mean our ion concentration is too high, or is our ion concentration too low? Is it too small or is it too big? It is too small. Therefore, will it precipitate form? This is like you don't have enough guests at the hotel, so there's no people left outside. Yes? So no precipitate will form. And is the solution saturated or unsaturated? Unsaturated, yes. Would you like another example, or would you like to try some on your own? One more example. I'll do one more example. If you're feeling like I would just like to try it on my own, you can go ahead and just go to the exercises and try it. Okay, but I will go through one more. Okay. So this is the second example, and like I said, I mean, you can see how much space I left and how much space it took. I mean, honestly, some of that was because, you know, I was writing explanations and things. Really, when you get good at this, the calculations aren't that long, okay? You know, you're not writing down all sorts of things all over the place. So our second question, we have 50 milliliters of 0.1 molar lead nitrate. So let's see, what was our other one? Oh, it does not want to move. Now it's moving too much. What is wrong with this thing? Okay, there we go. 20 milliliters of 0.04. Okay. Step number 1. I thought I selected red. There we go. What is step number 1 in a question like this? Yes. Identify the precipitate. So many students fail to do that, and then they get totally lost in the question because they don't even know what substance they're dealing with. Yes? So if you are given 2 substances, you must identify the precipitate. It is. Your precipitate is lead chloride, PbCl2. Yes. I will not give you 2 precipitates in a question like this because it's just like too many factors going on. Yes? Only in like the sense of here, write the complete ionic equation, write the net ionic equation, like the ones you had on the last quiz, that kind of thing. Second thing we want to do is we want to find the ion concentrations. So we are looking for here concentration of lead, and we are looking for the concentration of chloride specifically. What kind of calculation will we have to do here to find these? We're going to have to do a dilution calculation, okay? Because we're mixing two things. Okay, so let's start with our lead. Pb2 plus. Is lead 2 plus going to be the same as the concentration of lead nitrate? Yes, because there is one lead in lead nitrate. So my concentration of lead will be the same as my concentration of lead nitrate because it is 1-to-1 lead to lead nitrate. If we want to use the Noon formula, what comes first? Old concentration, so this is going to be our new concentration here, right? This is our new concentration, and we find that by multiplying our old concentration, 0.10 molar, times our old volume. What's our old volume? 50 milliliters over our new volume. What is our new volume? 70 milliliters. And we get 0.1 times 5 divided by 7 is 0.07143 molar. I probably don't need that many digits, but I'm going to keep that there just in case, okay? So that is our lead concentration, Pb2 plus. I'm going to put a box around it so I can find it easily later. We also want our chloride concentration. Is chloride going to be equal to sodium chloride? Yes, because it is 1-to-1, yes? So chloride is equal to sodium chloride diluted, which is old concentration, 0.040 molar, times old volume, 20 milliliters, over new volume, 70 milliliters. 0.04 times 20 divided by 70 is 0.01143 molar, and that is chloride. So number 1, identify the precipitate. Number 2, find the ion concentrations. Number 3, what do we do? Solubility equilibrium equation. Who are we writing it for? PbCl2. PbCl2. That's a solid in equilibrium with lead. 2 plus, aqueous, plus 2, Cl minus aqueous. What comes next? Q, it's a will it precipitate form question. If it's a will it precipitate form, that is a Q. Okay, so our Q is equal to the concentration of lead times the concentration of chloride. Squared. Squared. Can't forget the squared. There we go. So our concentration of lead, we just go back to our red box where we wrote it. And that is 0.07143. And the concentration of chloride is 0.01143 squared. Do not multiply your chloride concentration by 2. Do not multiply it by 2. Do we know why we're not multiplying it by 2? Because it's coming from silver chloride, which only has 1 chloride. It's not coming from lead chloride, which has 2 chlorides. Okay? So we do that and we get, let's see, that would be squared times 0.07143 equals 9.33 times 10 to the minus 6. Step 5, compare Q and Ksp. Q, which is 9.33, times 10 to the minus 6. How does that compare with our Ksp? 1.2 times 10 to the negative 5. How did you know that, Norman? Data booklet. Excellent. All right. So Q is, again, less than. Yes? Yes, it certainly will. Yeah. Less than Ksp. And therefore, what can you say? Will a precipitate form or will no precipitate form? No precipitate will form. And the solution is unsaturated. All right, and I would like to give you the last 20 minutes of class to work on these questions. Numbers 1 through 3 are for homework, okay? I mean, if you want to do more, you can do more, but you know, I think that will give you a good taste of it, and then we can do another one as review tomorrow, you know, that kind of thing, so. Oh no, tomorrow we're moving on. I want to finish Ksp math this week. I want to quiz next Tuesday. Let's see, it's E. How well do you guys remember titration? Okay, so it'll be E, F, G, H, E, F, G, H, I. But H and I are just like putting them all together in a big, massive, here's a bunch of Ksp problems. Hope you can pick the tool to use for each one. Okay, but there will be some help for you on that. It will help you like sort out which ones. Yeah, just those. Oh, I'm just going to press stop on the recording here because nobody wants like hours worth of nothing happening.